Hi students, and welcome to today's lesson. I'm Mr. Hunter. Today we will investigate the question, how do the time spans of Earth events that slowly change land compare to a human lifetime? Are you ready? Grab your pencil and your science journal and let's get started. Today we will take a trip to visit the Great Sphinx of Giza. I wonder if the Sphinx always looked the way it looks in this picture. Look closely at the face of the Sphinx. The Sphinx looks like it has a person's face, but the face is missing something. The nose is gone. I wonder what happened to the Sphinx's nose. I also wonder about the cracks in the Sphinx. Did the Sphinx always have those cracks? Let's read part of our book, World Traveler, the Sphinx, to see if we can find out more about how the Sphinx has changed over time. Read along with me. A Sphinx is a mix. This one has the body of a lion with the head of a man. It is crafted from limestone. Do you know what limestone is? Limestone is a kind of rock. People carved the Sphinx from the limestone found in the ground, so they made changes to the land. Interesting. Let's read more. Without the sand to hide it, the stone is at risk. Wind and sand chip at it. Chunks fall off. So what might have caused the Sphinx to change after people carved it from rock? Our book tells us that wind and sand caused the Sphinx to change. The story of the Sphinx reminds me of the Earth events that change land. I wonder, how does the event of wind changing the Sphinx compare with the other events on the diagram? Point to where you think the event of wind changing the Sphinx should go on our diagram. I think wind takes a long time to change rock. I would put the event near delicate arch and wave rock, which took thousands of years to form. The Sphinx may be 4,500 years old, so the wind may have been changing the Sphinx for 4,500 years. That amount of time is hard for me to imagine. Let's use a model to help us understand this very long time span. Our model will also help us answer the question, how do the time spans of Earth events that slowly change land compare to a human lifetime? In our model, a 1 centimeter piece of tape represents a time span of 7 years. Raise your hand if you know a 7-year-old. This end of the tape is year 0, and this end of the tape is year 7. Now, suppose a person is 70 years old. We will start the tape at year 0. Can you point to where the tape would end to represent 70 years? Did you point to the 10? If so, you are correct. The 10 centimeter piece of tape represents the age of a person who is 70 years old. Now, the Sphinx is about 4,500 years old. How long do you think a piece of tape needs to be to show a time span of 4,500 years? Will the tape be this long or this long? Actually, we will have to go outside to see how long the tape must be. Whoa! Do you see how far the tape that represents 4,500 years stretches across the side of this building? So, how does this model help us compare the time span of the Sphinx with the time span of a human life? When the pieces of tape are in a line, we can see that 4,500 years is a lot longer than the life of a 7-year-old student or even a 70-year-old adult. But wait a minute. If the Sphinx has been changing for 4,500 years, then no one alive today saw the Sphinx when it was first built. If no single person can observe the Sphinx changing over 4,500 years, why do scientists think the Sphinx has changed? Well, before we try to answer this question, let me show you a quick demonstration. This rock is a sample of limestone. It's the same kind of rock that makes up the Sphinx. I will hold the rock over a table and rub sandpaper against it. What do you see? I see that bits of the rock have broken off and fallen onto the table. The sandpaper rubbing against the rock is similar to wind blowing sand against the Sphinx. Now, let's watch what happens when we keep rubbing the sandpaper against the limestone. What happens? What do you notice? I notice that even more pieces of limestone fall off when I rub the rock longer. What do you think would happen to the limestone if we rub sandpaper against it for 10 more minutes? Or 10 years? I think that more and more pieces would fall off the rock until the only thing left of the rock would be little pieces. Does this demonstration support claims from scientists that wind and sand have changed the Sphinx over thousands of years? What do you think? Well, we saw that sand can make rocks change a little at a time. If the wind blows sand against a rock for a long time, the small changes will add up to a big change. So yes, I think the demonstration supports the claims from scientists. So can we answer our question now? If no single person can observe the Sphinx changing over 4,500 years, why do scientists think the Sphinx has changed? Well, scientists often observe present-day Earth events to learn more about how the same kinds of events happened in the past. Scientists can observe wind causing tiny changes to the Sphinx today. So they believe it is very likely that wind has been slowly changing the Sphinx ever since people carved the statue from limestone over 4,500 years ago. Wow! We have learned so much about the time spans of Earth events and how they compare to a human lifetime. Let's add everything we have learned about timescales of changes to land to our anchor chart. Some Earth events happen quickly and change land over a short time. Some Earth events happen slowly and change land over a long time. Scientists observe present-day Earth events to understand how land may have changed in the past. I wonder, do we know enough now to better explain the changes to Surtsey? How can the island of Surtsey change shape over time? Well, we know some Earth events happen quickly and some happen slowly. Think about the changes to the land of Surtsey. Surtsey formed from a volcanic eruption while water and wind continued to change the land. Where do you think the time spans of the events that have changed Surtsey would be on the diagram? In the next lesson, we'll explore more about the time spans of events that change land including those that affect CERTSI. Let's review your tasks for today. First, fill in the blanks to update the anchor chart. Next, look for evidence of changes to land or an object. Sketch what you find. Explain what may have caused the change. Thanks for joining me on today's journey as we investigated how the time spans of Earth events that slowly change land compare to a human lifetime. Your task for today is to complete Lesson 20 Science Journal. I'll see you next time.